Let's solve this exponential equation. So first, let's do some rewriting of this exponential equation. I'm going to rewrite this term 7 power 2x, and this can be written as 7 power x plus x. So this equals 7 raised to the power of x times 7 raised to the power of x. So this equals 7 raised to the power of x quantity squared, because we are multiplying 7 power x with itself 2 times. So therefore we can write this in exponent form as 7 raised to the power of x quantity squared. So I'm going to write down this 7 power 2x as 7 raised to the power of x quantity squared, plus we can rewrite this 7 power x plus 1, and this equals 7 power x times 7 power 1. Basically, we are using this rule of exponents, that is a raised to the power of m plus n equals a raised to the power of m times a raised to the power of n. So we are following this rule and rewriting this. So now I rewrite 7 power x plus 1 as 7 power x times 7, and then I put this negative 60, and this equals 0. Now we see that we have this factor 7 power x in the first term as well as in the second term. And so let's do some substitution here. I'm going to put 7 power x equals t, so that we can write this exponential equation in simplified form. So let's put 7 power x equal to t into this equation. So we will get 7 power x equal to t. When we replace it, we get t squared plus 7 power x is replaced as t. So therefore this becomes t times of 7 minus 60, and this equals 0. We can write this as t times of 7 is 7t minus 60, and this equals 0. Observe that this is a quadratic equation. We can solve either by factoring method or by quadratic formula. I'm going to split this into product of two linear terms. So let me put this as t plus, and then we will have t. So the factors are positive 12 and negative 5, because when you multiply 12 with negative 5, we get negative 60. That is, the product is negative 60. And when I add 12 with negative 5, we get negative 7, which is, I'm sorry, it is positive 7, which is the middle term. So it is perfect. And this equals 0. I can put this little bit closer. So it's a product. Now we can solve for t from these two factors. That is, t plus 12 equals 0, or t minus 5 equals 0. So we get t equals negative 12, and t equals positive 5. Okay, so now we have found the values of t, that is t equals negative 5 and t equal to 5. However, we have to check if these values satisfy the equation. That is, we have made the substitution 7 power x equal to t. So let's see what happens when we put in that substitution. So we have 7 power x equal to negative 12. Remember that this is an exponential function. It's basically an increasing function. That is, if you plot the graph of this function, it will look like something like this. Just sorry about it. So I can put it like this. It increases. It's always increasing, and this is always above the x-axis. And for no values of x, this function is attaining negative values of y. And this means we cannot have any solution for this equation. That is, when t equals negative 12, we don't have any such values of x, such that 7 raised to the power of x gives negative values for t. And that means we can ignore this value of t. Let's substitute t equal to 5 into the function, that is into the substitution. So we get 7 power x, and this equals 5. So clearly we can get some values of x, because x is 7 power x is increasing function, and so we can get some values for x. Let's see how to solve this exponential equation. First, I'm going to take natural logarithm on both sides. So when I do that, I get natural logarithm of 7 power x, and this equals natural logarithm of 5. I'm going to put this x in front. This is according to the power rule of natural logarithm. So therefore, this becomes x times of natural logarithm of 7, and this equals natural logarithm of 5. Now you can easily solve for x when we divide both sides by natural logarithm of 7. So therefore, we get x equals natural logarithm of 5, and this is divided by natural logarithm of 7. And so this is the exact value of x, that is natural logarithm of 5 over natural logarithm of 7. In fact, we can give this answer in terms of decimals. So when we plug this expression into the calculator, we get x as approximately 0.8, so I'm sorry, 8271, and this is approximated to 4 decimal places. So I have given both the exact value as well as the decimal approximation for x. So this is a solution to the given exponential equation.